we're on 5.3. Okay, go ahead and open up to 5.3. So finally, we're going to learn something kind of new. We're going to start learning how all this stuff we've been doing the last few months applies to how to graph it, which is kind of the point of what we've been doing, okay? So the graph of a quadratic equation is in the shape of here's a new shape, you know, like shapes like in elementary school, like circles, squares, okay? So we're learning a new shape today. It's called a parabola. That's good. Parabola, okay? All right? So that U shape, guys, this should be a pretty easy lesson for us to get through because we're just learning about key features of graphs, okay? We don't have to do much of our old stuff today. Let's get through it, okay? Can anyone think of, like, where in the real world you might see a parabola?
No.
Nowhere? Has anyone ever shot an arrow?
The letter V.
Okay. The letter V? Well, how about the letter U? Okay, all right. Okay, so if I shoot an arrow, right? It goes like that. Right? Shoot a free throw. Basketball is an upside down parabola, right? What if I had some water and there's like a little fish right here? Right? And then this bird.
What kind of fish?
The Jesus fish. That's why I drew it like that.
Jesus?
Yeah. Right? And then they dive down to catch the bird and then fly back up. Parabolas are actually in a lot of places. Okay? All right. Key features. So the important parts. Okay? Do you guys remember from last year what an intercept is? Not intersection, intercept.
Isn't that
Victoria?
where the line?
The line? This one, the axes.
Yeah, that thing.
Good. The intercept is where it crosses the axes. Okay, good, Victoria. So the y-intercept of the graph is where the graph crosses the y-axis. Okay, what we're learning today is not just the vocab, but it's the notation. The y-intercept is a point. Okay, coordinate points have two things. Which one's first, the x or the y in a coordinate point?
X.
The x. So on the y-intercept, what's the x coordinate going to be?
0.
Good. So on this graph, for example, the y-intercept is 0, negative 3. On your homework tonight, when you type these answers in on Canvas, you have to be so careful with your notation. If you put negative 3, it's going to mark it wrong. Half the battle is the notation. Okay? Okay, the x-intercept is where the graph crosses the x-axis. How many x-intercepts is this graph going to have? 2. Okay? That's different than the linear equations you guys did last year, right? Because I didn't have a bend or anything. So it would only cross once, but this time it crosses twice, okay? So on this graph, it's going to be negative 1, 0, and 3, 0. Can someone raise their hand and tell me or how I knew the y coordinate? Someone raise their hand and tell me, how did I know the y coordinate? Raise your hand and tell me, raise your hand and tell me, raise your hand and tell me. Oh, everybody in class is willing to answer when you can just shout it out?
Yeah.
Michaela, thank you.
Because it's where the dot on the x-axis, or where it crosses on the y.
X-axis. Yeah, you were right. So where it crosses on the x-axis, that y coordinate's always going to be 0 on the x-intercept. Good. Okay, the axis of symmetry is a line down the middle. You guys remember what symmetry means? It's like the same on both sides. You guys used to use symmetry to make Valentines, right? You fold a piece of paper in half and you cut out half the heart. Does that make sense? Okay. So it's a line. How do I write the equation of a vertical line? Nope. It's not a point, it's a line. Anybody remember? I know it's been a while. What is it? Oh, that's a good guess. That's for diagonal lines. Yep. Okay, what about vertical lines? Vertical lines are x equals lines. So the axis of symmetry on this one is x equals 1. Okay. Okay. The vertex of a parabola is a point where the graph turns. Take a second with your neighbors and see if you can decide what the vertex of this one is. Okay? Thank you so much. Does anyone think they could raise their hand and tell me what they think the vertex is? Gavin?
1 negative 4.
Awesome. 1 negative 4. Okay. So far, so good? Okay, my next question is, can someone raise their hand and define for me what is a minimum and what is a maximum? Don't think about this graph. I just want to know, what do you think these words mean? Highest and lowest point. Thanks for saying it. Next time, raise your hand, yeah? Thank you, my dear. Okay, so minimum is the lowest, maximum is the highest. Parabolas can't have both because they go up or down in one direction forever. So when I say minimum or maximum, what I'm asking you is the vertex a min or a max for this graph? Okay, on this graph, which is it? A minimum, because it's the lowest point on the graph. I'm lazy, so I just wrote min. No, just this one does. Okay, that's a good question, though. If I had a parabola that was upside down instead, would that one have a minimum? No, that one would have a maximum. I can't have both. Okay? Yeah.
So if that were just upside down tracking, like, then that's how they discovered it, and that's how it.
We're going to learn in the next week or two, what makes a parabola upside down or right side up. Okay? Okay. All right, next, domain. The domain is all possible x coordinates of graph. So if I could make a list of every single infinite point on the graph, right? Not just x-intercepts, every single point on the graph, and then I took all the x coordinates out and I made a list, okay? What would that list look like? Okay, I want you to think for a second. Can you guys think of any number on this graph right here that wouldn't be in my list? 7? Well, look, this goes forever up, right? So won't it eventually get to 7? It'll just probably be like way over here, right? Is -2, would that be a possible x coordinate in the list? Sure, on that point right there, right? Are there any x it is infinite, okay? Every possible graphable number is in the domain of this one. I know it's been since Unit 2, but does anyone remember our vocab word for any possible graphable number? I think I heard it, Hudson. What is it? It is real numbers, okay? So we would say all real numbers, or the lazy person's way. Remember those shortcuts that we did, right? Anybody remember the shortcut for real numbers? No, it's just an R. Jeez Louise. Remember we learned like natural was N, whole was W, real was R. Okay? Okay, so the range is all possible y coordinates. Okay? Okay, so let's look at the graph right here. Do I have a point on this graph that has a y coordinate of like 5? I have 2 of them, right? Right? If I wrote this point, it'd be 4, 5. That one would be negative 2, 5, right? Is there a point on this graph that has a y coordinate of negative 5? No. Notice the graph doesn't, the minimum of the graph is negative 4, right? So there's no y coordinates lower than that. Does that make sense? Everybody with me? Okay, do you guys remember the inequality signs? We have less than, greater than, less than or equal to, and greater than or equal to. Okay, we're going to use these for range. So I would say that my range is y has to be greater than or equal to, no, not 4. Negative 4, yeah. Okay. I know it can be equal because my vertex went to negative 4, right? Okay. We're almost done with the vocab, and then I'm going to have you guys try some of these, and then we'll learn how to do this stuff on your calculator. Okay? Increasing. Okay, we read. Oh, yes, please. Yeah, go ahead. There's a sign out list over on the board over there. Okay, increasing. Okay, so we read graphs like a book, meaning left to right. Okay, I start at negative infinity, and I go at the left, and I go to the right. Okay, you guys with me?
What the frick is negative infinity?
So do you know what infinity is?
Yeah.
So at negative infinity is just infinity going to the left.
Infinity is the circle.
Well, the infinity, that's the circle shape, but in terms of numbers, if I have a number line, 0, 1, 2, 3, 4, if I kept counting up forever, I'd get to positive infinity.
I guess that's
And then if I kept counting down forever, I'd get to negative infinity.
yeah,
Okay? So here's what I want to know. Is this graph at the beginning increasing, meaning getting bigger, or decreasing, getting smaller? Decreasing. Until when? When does it stop decreasing? At the, tell me the vocab word. Where? At the vertex. And then what does it start doing? Increasing. So what we would say on this graph is that it's increasing right of vertex, and it's decreasing left of vertex. Okay. Okay, our last one, direction of opening. We call that, on this one it opens up, right? The opening is towards positives. So we call that concave up. Yes. Yes, that's the vocab word for it. That's what we're learning today. Okay, if it opened down, we would have said concave down. Okay? All right, what I'm going to do now is I'm going to walk around and help. The best way to learn some of these is to practice. What I want you to do is I want you to look at